Okay, so in the last video we saw that we could construct this minimization problem that we had last time. And this minimization problem is actually called a linear program. So the word program, or the word programming, for example, a mathematical program, isn't like a computer program. It's more of setting up an optimization problem. Okay, so when you hear the word program in operations research, it doesn't mean the same thing as a computer science program. Okay, so in this case, we have a special type of optimization. Like I said, it was a linear program, and so those are the types of optimization problems that we're going to focus on the most. So let's go ahead and just write down the general form for a linear program. So general form for a linear program, LP. Okay, so we're going to have our objective function, and that's going to be some z is equal to, and now the way we want to write it is we're going to try to maximize. Oh, I shouldn't write it like that. Let me go ahead and write it this way. Max or min, we'll just go ahead and write it as a max. Z equals like omega 1 x1 plus omega 2 x2 plus omega n xn. So notice that this function is linear in all the x's. Okay, and then we have such that the constraints are true, and so we'll have a11 x1 plus a12 x2 plus a1n xn is less than or equal to b1. a21 x1 plus, do you see how this is working? a2n xn is less than or equal to b2, and so on. And then a m1 x1 plus a mn xn less than or equal to b sub m. Good. And then typically you also have the x's being greater than or equal to 0, although that's not absolutely necessary. Later on in the chapter we're going to figure out how to deal with it, deal with the linear program if that's not true. Okay, but notice that this is a linear function with linear constraints. Okay, now there are some assumptions that we have to make about our situation in order to build this kind of a model. So let's just run through some of the assumptions that we would have to make. Assumptions. 1. Proportionality. That is, the contribution of each activity to the value of the objective function is proportional to the level of the activity. So for example, you could say you have x1 is the activity, then you would have to say like omega 1 x1 is the contribution. That's what we mean by the proportionality assumption. What's not proportional? So not proportional would be something like fixed costs. So for example, suppose it takes you 10 units, or the profit might be 3, instead of just omega 1 x1, it would be omega 1 x1 minus 5, where 5 is our fixed cost, right? So that would be not proportional. Okay, similarly, there might be economy of scale. So the profit might be something like 3x1 if x1 equals 1, and then let's say oops, I didn't want to put that, but just 3 if x1 is equal to 1, 7 if x1 is equal to 2, let's say 12 if x1 is equal to 3, and so on. So do you see what's happening here? We're making more and more profit the more and more the x's go, and this is not proportional, right? Not proportional, because this would be 369, right, if this were proportional. So that's another example of not being proportional. So again, what did we need? The contribution of each activity, for example, x1, to the overall profit is proportional. So that means omega-1 x1 is the contribution. Good. So there's another thing that we need to add in here, and that is additivity. Right, and so that means that the if we have like omega-1 x1 being the contribution of x1 to the overall profit, and then omega-2 x2 is the contribution of the next activity, then the overall contribution would be found by adding those. So omega-1 x1 plus omega-n xn is where this is additive. Where it would not be additive would be something like, you know, the profit, not an example. You know, if you have for x1, let's say the profit is 3x1, and then for x2 only, the profit is 5x2. And so then if you add, if we have both, let's say that the profit is 15x1, x2. Okay, that would be an odd thing, but that would not be additive, right? What would be additive is to say that the profit is 3x1 plus 5x2. Okay, so that's what we mean by that. So 3 is divisibility, and that is that the decision variables are real numbers. Okay, that way our domain is some subset of the reals, and that's a condition for our techniques for finding the max and min. If the decision variables are not actually real numbers, sometimes you can get around that a little bit. So for example, suppose that x1 is the number of chairs you're going to build in some problem. Well, you can't build half a chair, right? So that would actually violate the divisibility problem. But you might think that, well, maybe I could just round up or round down. Sometimes that works, but sometimes that doesn't. So we're going to see examples later on of each of those cases. But for the general linear program, we want the decision variables to be real numbers. In the general, let me say that again. In general linear programs, we want the decision variables, x1 through xn, to be reals. Okay? And finally, certainty. That is, we know what our profit is with certainty. For example, our profit is 3x1 plus 5x2, and it's not a probability distribution. So for example, you know, the probability of having a certain profit is some given percentage. So no statistics here. Everything is known with certainty. Okay, so that's really important for sensitivity analysis in particular. Okay, good. All right, so let's review those four again, just to be sure we got it. Proportionality is the first assumption. Proportionality, again, meaning that the contribution of each activity to either the profit function or one of the constraints is just a constant multiple of that activity. Okay, additivity means that if you have more than one activity present, the overall contribution is going to be taken by the sum. So not a product, not a difference, not a product or a quotient. Divisibility means that all your decision variables are real. And finally, certainty means that we know those coefficients with certainty. We're not assigning some kind of random variable to those values. Very good. All right. So I think I'm going to pause here. And then there's just a couple of extra things that I wanted to mention, and then we'll review some of the vocabulary.